Hello everyone, this is Singh 𝐒𝐲𝐬 and I'm back with another discussion video in which we will be talking about caching architecture at DoorDash. So if caching, if you don't know, is a technique which you generally use to make the responses of the APIs faster. And the way you do it is that let's say you are fetching some data from the database. Okay, database generally stores the data on disk. So to improve the performance, you want to keep some data in the memory. Memory access is faster as compared to disk. So this is what we mean by caching. This is your cache solution, cache DB, which talks to this DB, or like tries to keep in sync with this DB, so that whenever a request is made, whenever a popular request is made, they can be served by the cache instead of hitting the DB with so many queries. Okay, so this is the general idea of caching which we try to use, and today we will talk about the caching architecture which is being used by the different services at DoorDash. Okay, what is the current solution implemented, and what were the some problems with it, how it was made more generic for the teams to use. But before we move forward, if you haven't subscribed the channel MsDeep Singh, consider subscribing. I keep on making great content such as this video where we keep on discussing different architectures on how different companies or organizations manage their large scale applications or large scale traffic. So you will learn a lot of things, and also consider looking into the book System Design on AWS, which is written by me along with my co-author Jayant. This book talks about the general system design concepts, focuses on different AWS services which are mapping to different domains. Let's say what are the database services, what are networking services, what are storage services, something of that sort. And then finally, we will talk about different use cases, or like actual building of applications, such as let's say hotel reservation application. How can you build it, and then finally how can you launch that system on AWS. So you will learn a lot of things, and there is a specific chapter which talks about caching solutions and strategies, which talks about what is caching, then also what are the different caching strategies, how can you invalidate cache. So everything related to caching you will find in this book. So this is right now available on O'Reilly platform, and it will be soon be available in the hard copies. By the time this video is out, you should see the hard copies on Amazon, okay, and other online websites to buy this great resource to learn system design and then how you actually deploy those applications on AWS. Okay, coming back to our discussion in which we are focusing on caching architecture at DoorDash. Great. So what is the problem statement? Our problem statement is, now if you talk about the caching, right, I took an example that you try to make your queries faster with the caching. Okay, you are trying to keep some data, and the first, generally you heard terms like Redis and memcache. Okay, and there are other popular more solutions as well, like available right now these days, such as Wall-Key, okay, or Dragonfly DB. So there are a lot of these solutions which are available in the market, and these are the general terms whenever you heard about caching. Okay, whenever someone asks you that how can I make my response faster, you will say, okay, introduce Redis. So all those things. So what is the problem statement with it? Okay, so what is the problem, basically what we are trying to achieve? This is your requirements per se. So whenever you are trying to design a system, you try to come up with the requirements, what I'm actually trying to do. What is the requirement? Okay, so the general idea is that every team at DoorDash is managing their caching architecture. Okay, and somehow we want to simplify that. Every system, or like every team for their applications, introduce a cache in between. Okay, this is your, let's say, cache in between, and then finally it goes to a DB. So every team is managing this caching solution. Every team has the extra operational overhead of management of this cache. How can we simplify that? Can we do that? Okay, and another thing is, let's say some examples we took, right? One team is using Redis, one team is using memcache. Okay, so there is a lot of extra expertise which is required, or much similar on the operational overhead terms. Okay, so these things, there can be multiple caching available. Okay, there can be in-memory cache, these like extra caching layer, or it could be also possible you are keeping a cache on the service instance itself where the application is running. So how can you introduce a generic interface? So this is what we are trying to do. Okay, so each team manages their own data and exposes via gRPC APIs. Caching is used to improve performance, that we already talked about. Reduce cost, how? Because you are not actually hitting the DB, so DB don't have to be scaled to serve that much of traffic. So most popular queries can be directly served from your caching solution instead of hitting the database. Okay, this is what we mean by reducing the cost, because you are saving on that infrastructure. There are different approaches followed by different teams, so this is also we talked about. So these are the problem statement, these are the requirements. How can we come up with a generic solution which can be used by each and every team? So basically we are trying to build a multi-tenant system. Customers use this system of caching, is basically an interface or whatever you can say, library. They can use the system to keep their cache, store their cache, and then access it when serving the API responses. These are the existing caching solutions which are already in place. You have Caffeine for like local caching, and then Redis, Lettuce for distributed caching. So talking a little bit about these. So if I try to explain you how caching is generally implemented, so let's say this is your user. Okay, this is your user, uh, handsome user Mandeep Singh Shekhawat, and then this user is trying to get a food item. Okay, trying to order a biryani. So he goes and search biryani on DoorDash platform, and then DoorDash platform looks for the biryani. This is near the location. Okay, so first it checks in the cache. Okay, if it's not available in the cache, then it goes to DB. Okay, so this is the first layer of cache in this architecture. What we can do is we can further simplify this. Instead of going outside of this machine, okay, so this DoorDash application here, let's change the color. So this DoorDash application here is deployed on, let's say, Kubernetes. Okay, so you have multiple pods here. So what you can do is you can also keep a copy of the data. Copy of, let's say, biryani is highly loved dish, so people are continuously carrying. So instead of hitting this cache also, you can have one layer before it. Okay, so you can store the data at the instance. Okay, so Google Gavava is one popular implementation. Caffeine is implemented on top of it. So what you can do is you can maintain the cache on top of your machine itself, machine instance itself. Okay, the application where the port where the application is running, and then if it's not available there, then you go to a cache such as Redis, and if it's not available there as well, then you go to the source of truth, which is your persistent database. So these are the general layers, and we will also talk about one more layer before this as well in later down the video. But you got the idea, right? So you are trying to improve that performance. So this is what we are doing. So here, to implementation per se, okay, you are using Caffeine. You can just understand this as a library. So you are basically storing the data and then you are retrieving the data. This Lettuce again is a client which you can use to simply access the data. Okay, so basically you are setting the data, you are getting the data, all those operations, and it very well works with distributed set of Redis instances. So if you are running a Redis in cluster mode, so this Lettuce is a easier library to use. If let's say you have a single or a standalone cluster, then we recommend, not we, I recommend Redis to use. It's a simple implementation for standalone clusters. Great. So what are the problems with this architecture? If every team is implementing this Caffeine for local caching and then Redis Lettuce for distributed caching, what are the problems? First thing is, cache staleness. Cache should remain updated with the original data source. This is not a problem per se, but this can be a problem if the data is stale and it is not regularly updated. Okay, so you might be serving older data to the customers. Dependency on Redis, service issue with Redis. So we talked about we talked about that a system is hitting to this Redis. Okay, what if there is something wrong with this library? Okay, what is something wrong with this library, or not library per se, Redis instance? So how can the external clients, or like external, when I say external, internal teams basically, okay, how can those clients be abstracted out by this bringing down this, or let's say in future instead of Redis you are using memcache. So for every team there is not a hard dependency. Okay, so there is a dependency on Redis, and how I want to remove that somehow. Great. No runtime control. Introduction of new cache changes require new deployment or rollback in cache of issues. Okay, so let's say you are introducing a new caching solution. How will you implement it? Again, instead of Redis, let's say you have two caches in place. You have memcache as well. Okay, so these kind of requirements. Okay, inconsistent key schema. Okay, so there are multiple teams which uses it, so there is no consistency in how the keys are created. When I say cache is basically your key value pair, right? So you try to access a key and then it gives you the value for that particular key. So there is inconsistency on how different teams are using it. Observability means how you have set up different metrics and alarms. Okay, so you should have proper uniformity across the metrics, so you can figure out how the data was stale. Okay, what is the cache hit rate, what is the miss rate. Okay, so these things, if the data you have faced some sort of errors. Okay, so you have to have proper metrics in place for at a client level, at a tenant level, that yeah, this is the cache hit rate, like at how many times I'm getting the data from hit rate basically means at how many times you are getting able to retrieve the data from Redis instead of going to the actual database. Great. Support for multi-layer caching. So I want to support this multi-layer caching. You have multiple layers. We talked about one is caffeine, one which Redis, and then we will also introduce a request level caching as well. So you want to support 3 layers of caching to serve the data. Great. So these are the problems, and these are also our requirements, that these are problems with this architecture. So how can I create a new architecture? How can I design a new architecture? How can I launch a new architecture to address these problems? Great. So what's our solution? Solution is to create a single interface for the clients to hide all caching complexities. So we are trying to design a multi-tenant system. We are trying to design an interface basically which has a consistent schema. It provides the APIs. You talk to those APIs whenever you want to store the data, whenever you want to retrieve the data, and that interface handles your internal abstractions or internal implementations, internal complexities which are there involving multiple layers of caching. So this is our first thing which we have to do. Support multi-layer cache. Key request process through 3 layers until key is found or reaches original data source. What are these 3 layers? So what are these 3 layers? First one is request level caching. When I say request level caching, so let's say this handsome user Mandeep Singh 𝐒𝐿𝐴, where is that user? Here is our user Mandeep Singh 𝐒𝐿𝐴. So this user is searching for biryani. So at the lifespan of this request R1 is that you search for that data and then it is returned. Okay, so in a single request as well, there is a possibility that you are trying to access that data multiple times. Okay, there is a possibility that you are trying to access that data multiple times. So how can you do that? You basically store that in a hash map, so that whenever it is trying to access, instead of going to that application level cache as well or going to that Redis as well, you can extract the data before as well. Basically you are trying to improve the latency of how you are accessing the data. Okay, so this is your request level cache. Another cache is your local cache. Local cache is your caffeine implementation, which is uh, specific to your pod. Okay, where your application is running. In this case, your all the workers of JVM, basically all the threads of JVM which are running on a single pod, can access this data. What is the cache which is accessible to all these ports? That is your distributed caching solution. For that we are using Lettuce client, and you have your Redis implementation for that. Okay, so these are the different layers, and if you do not find the data in these 3 layers, then you finally go to the where you go your source of truth, which is your database, your persistent database. Let's say your Postgres or DynamoDB, something of that sort. Great. Okay. So what are the features we are getting out of this system? I'm hoping that you understood how different layers of caching are implemented, or like what is the expectation from the solution which we are designing, whatever architecture we are designing. What are the features? First feature is runtime control to turn on and off specific layer in multiple layers. Okay. We mentioned that there are 3 layers. If I say that I want to switch off this request layer, or I want to switch off this local layer, how can you do it? It should be able to be implemented, or the clients, not clients should have easy configuration options to do that. Okay, setting layers TTL. How much time does it take to remove the data, or like consider data as tail? Okay, so that's the TTL which you can define, and it can be defined at each and every layer. Great. Another thing, shadow mode for specific percentage. A percentage of request to cache is also routed to original data source for value comparison. So what you are trying to do, okay, you got the data from this Redis. Okay, this is your R1, but you are also hitting that data to this, also hitting that request R1 dash, okay, to your database, and then you basically compare the value v1 and v1 dash. Are they equal? If they are not, you publish a metric and also update that cache. Okay, this is what we mean by shadow mode for specific percentage, so that you figure out, let's say it can help with your TTL as well. Okay, like in how much time your data is going to be stale, and then how frequently you should update this data. Okay, collect metrics. Definitely we want this collection of metrics. Okay, error logs for cache misses. We also want to print the log so that you have the metrics, and then if you want a further debugging capability, you can do that. Okay, standardized key schema. This is one of the problem, that there is an inconsistency. Where is that inconsistency? This is the inconsistency. So we have inconsistency in the schema which is defined by the clients. So we want to ensure that there is consistency maintained. If you look at the key, this is the consistency. You are in DoorDash, this is your constant kind of thing. Cache key type, then ID, then cache name. Okay, this is not named name. Okay, cache name. So this is the consistent schema which you are maintaining. Okay, for this particular key, get me this data. Okay, this is the implementation. You can also check in the blog. It's the simple interface to get the data. Okay, so some general things to talk about: when to use caching and when not to use caching, and then some cache invalidation triggers. How can you implement those? Okay, so let's quickly cover those, and then we will end the video with this great discussion. Okay, so when to use caching. Can you tolerate stale cache? So if you are able to do that, okay, so if you are able to do that, or you can say you are fine with the eventual consistency, that I don't want, it is okay for me to get the stale data. So I was trying to search for biryani. Okay, let's say a new restaurant was introduced. Right now the cache has only 4 restaurants. Okay, so it's fine for some time. If the API is returning only 4 restaurants, in some time it will be updated to 5. Okay, so that's the kind of use case we are looking at. So you have to figure out a use case in which a caching is fine to support the user queries. Okay, few minutes of delay is acceptable, safe to use 3 caching layers with TTL. Okay, another thing is, if you cannot tolerate stale cache, so in that case your TTL will be seconds and few milliseconds, and your request caching is useful and local caching not so much. Okay, your request caching is helpful in this case, but your local caching is not that much helpful, because again it introduces an extra effort to invalidate cache, because the time is very less. Okay, the time is very less, so the data you are keeping and then you are also removing, so introduces extra complexity, okay, to handle that. Now we know that data has to be moved out. Okay, the data has become stale, and then we have to the data has to be moved out. What is the thing which you can use? What is the implementation you can use to remove the data from the cache and then update it with the most updated entry from the database? How can you do it? There are 2 mechanisms basically. First mechanism is CDC event from the database. Another thing is you handle it in your code implementation. We will talk about each and every one of them, and then you can decide which one is better for your use case. Okay, CDC event from database. Okay, so this is your DB. Okay, and this is your, let's say, write request or write or update, anything. Okay, you are trying to update, or you are trying making a new entry to a database. Now every time an entry is written or updated, you publish an event. CDC basically means change data capture. So whatever change is happening in your data, you are publishing the events. Now if the data is updated, okay, if the data is updated, your cache listens to those events, okay, consume those events, and based on that it can update those entries. So this is one of the mechanism. Another mechanism is whenever the db is updated, okay, so you have some db.write in your code. Okay, so whenever your db.write operation is happening in your database, simultaneously you also update the cache. Okay, so this is one, this is two. You are simultaneously updating the cache as well. Now every every approach has benefits and every approach has downsides. Now what is the downside of the cdc approach? The downside of cdc approach is that it is publishing the event, it is consuming those event, and then the cache's entry is updated. Okay, so there is some latency introduction. If I talk about this, there is no latency because you're kind of simultaneously writing to database as well as to cache. Okay, but that this db.write operation can be present at multiple places in the code. So at every time you are updating the db, you are also handling to be returned to the cache, and you have to figure out those scenarios in which you have to update the cache. Okay, so these are the two invalidation triggers, and it depends on the use case, basically business use case, basically which fits best for that time. When not to use caching? You should not use caching when. Okay, so first thing is write or mutation flows, write to database and read the value back from database. Okay, so if there is some write query happening, okay, write query happening, and at that time you also wanted to read the data, so at that point of time you should read the data directly from database instead of cache, because there can be stale entry present in the database. Take an example. Take an example of counter which you are maintaining. Okay, take an example of counter which you are maintaining in this database. Okay, so let's say my counter value is 5. Okay, and it pushed the cdc, and then your counter should be updated here as well. But again, as we said, there can be some introduction of latency. So right now let's say the counter is 4 only. Again, I got a write operation. Now the counter has to be incremented by +1, so counter has to be changed to +6. So what to do? Instead of getting the data from db, you access the data from cache, which is value 4. Okay, if the value is 4, what you are saying that the data should be incremented to 4 plus 1 to 5. Okay, it is already 5, so you are missing that point. Okay, so in that case you should directly access the data from db, which is 5, and then increment to it 6. Okay, there is no point at this point of time, because you understood the concept, right? It can create issues in your architecture as a source of truth. Second point is, as a source of truth, you should not use cache as a source of truth for your architecture. So this is all about today's discussion. I hope you enjoyed the discussion, you learned something new, and how caching is implemented at DoorDash. Okay, why this pen is not working? It is not working somehow. But yeah, consider subscribing the channel MsDeep Singh, and then consider looking into the book System Design on AWS. We will meet again in our new architectural discussion with more insights. Till then, stay safe. Tata. Bye bye.